I'm joking. It's dull. Okay, well, I'll kind of kick off because I'm obviously standing between you and lunch. And for that reason, I'm going to make sure it is 40 minutes, a little bit of time for questions. And I've actually removed some demos from this for two reasons. Firstly, I don't really want to be pushing a product, which is the T-shirt I'm wearing. I'd rather just talk about the general concepts so that you guys can decide whether or not you want to investigate the product a bit more, or take the concepts and apply them to your own HTML5 apps. So yeah, this is about how to build single-page HTML5 apps that scale. A very long and catchy title. I've noticed there's a lot of long titles here. It seems to be a theme. My name's Phil Legater. I work for a company called Kaplan Systems. This is a architecture diagram of the stuff that Kaplan do. So we help customers build web trading platforms, so full end-to-end solutions integrating with back-end technologies, but also building front ends, so HTML5-based trading applications, and mobile, native, and so on. But the focus here is obviously HTML5. We've been doing this, I joined Kaplan for the first time in 2001, and we were doing JavaScript, heavy JavaScript front ends that only ran in IE then. And now, obviously, we've got better browser standards, so we can target any reasonable front-end browser from IE8 kind of onwards. Over the past few years, we kind of build these large trading applications, all in running in the browser, and we came across a number of pain points. So what we did is we kind of reverse engineered the problems that we were having, and tried to create tooling to promote and to make a consistent way and to follow conventions for building these large HTML5 apps. And we've created this tool called BladeRunnerJS and open sourced it. I've got this little spinny thing that comes in to remind me that it is open source and people can use it for free. So this is the tooling that supports building these applications. I'm going to talk, as I said, about the concepts. I'll probably mention BladeRunnerJS a few times, but it's really just about trying to think about these concepts when you build these applications. So first I want to define what one of these large-scale single-page HTML5 apps is. I'll provide a reference point of someone who's cleverer than me. So there's a guy called Adi Osmani who works for Google. Before he worked for Google, I think he worked for AOL. And he spent a lot of time there looking at JavaScript architectures and thinking about front-end apps. And this is his quote around what these large-scale apps are. And the kind of key things are that they're non-trivial applications, so they're complex. They require significant developer effort to maintain, so they're probably a large code base. They're going to be around for a while. They require maintenance. And most of the data manipulation and display, and in fact, a lot of the logic is actually pushed to the browser. So we're seeing that, that's a continued trend, and that isn't going anywhere. We're going to be doing more in the browser. So that's a really good starting point. I want to dive into that a little bit more. So no matter how good a developer we are, the more functionality we want to offer in our application, the more code we're going to have. There's a couple of seats down here and one over here. Or a few over there, actually. If people want to come forward, don't worry. So we're going to have a lot of code in there. There's nothing we can do about that. As an example, our SDK has got 131,000 lines of JavaScript, 95,000 lines of test code, and then on top of that we build kind of example applications. We call them motifs because example kind of downplays them a bit. They're a trading application that customers can take and use and then build their additional functionality on top of, and they're 50,000 lines of JavaScript code. And in addition to all of this, we've got our other assets. We've got templates, HTML templates, CSS, images, ITN for localization, config, and any other resources. So these are large code bases. The next thing to consider is the complexity. Kind of what do I mean by that? So a good reference point. Who uses Gmail? Okay, most people. So we all accept it's a complex single-page application. We can do loads of different stuff in it. We can search and go through our email. We can filter our email by clicking on the labels. We can use the categories. We can look at our contacts by changing this little drop down here. We can look at our options. We can open up this compose view. And I really like this as an example. You can search your contacts in this too. You can do BCC and CC. You can add inline images, do attachments, look into Google Drive and add those attachments. So it's a complex application. This is Kaplan Trader. This is actually an old version of Kaplan Trader. And again, it's another example of a complex front-end application. And one of the interesting things I think about these things is that I think complexity takes a number of forms, the functionality it offers, but also the interactions that you make with that application. So the user here can interact in loads of different ways to achieve things with the application. But also the technology, the components that come together to offer to build that application. There's a lot of interaction goes on there. So that's components within the browser interacting with each other. There's interactions from the front-end code with the back-end code and multiple back-end components. So it's about all these interactions that go on too. So they're both these examples of large single-page apps, and they're generally, these two examples are the sort of things that you would maybe open and have open all day, or potentially open at the start of the week, or just leave it open as long as it keeps running. And that's the case with me with Gmail. I'll open Gmail and I'll run it as long as my computer's up. When I restart Chrome, and then I have to go to Gmail again. So the things that I'm going to talk about will definitely be applicable to, I've only got 4 minutes left on this clock, so I don't think that's right, hopefully. So I think it'll be applicable to single-page applications, but also applicable to any sort of complex website, something with complex interactions, those things that I've just spoken about. One of the things to consider is that because this application's around for quite a while, your features are going to change, new features are going to come along, but also as a product, you're going to identify features that nobody's using or isn't offering that much value, and they need to be removed. And the point here is that your architecture and your application needs to support that without providing too much overhead. So if you want to remove a feature from your app, you should just be able to pull the code out of your code base, maybe change a little bit of config, and that should be it. It shouldn't be a matter of refactoring the whole application. You shouldn't pull that feature and the application break. This is the best example I could find that's kind of a reference point. So, over time, Gtalk has changed. Video and calls became more obvious, and then we moved to Hangout. So this is the sort of thing we're kind of talking about. And as this changed, the whole of Gmail didn't have to change, just the way that this was represented did. The final consideration is the contributors. So this code base is large, it's around for a long time. You cannot have one person, unless you lock them in a dungeon, that codes this and maintains it. So you're going to have loads of different contributors. It could be that the person that created the application isn't even around anymore. So people need to be able to contribute and do so in a productive way. So you're going to have front-end devs, obviously. You might have back-end devs. You might have a cross-discipline team, people dive in and out of different technologies, which is great. We all can all get involved in that. Or it could just be that a back-end developer is on the same team, but they're defining services that your front-end interacts with. So they contribute in a kind of less obvious way. Designers might change HTML, CSS, add assets, remove assets, and so on. QAs might write tests, all part of this code base. So there might be multiple individuals, there might be multiple teams. In our case, we have a professional services department who work directly with customers. We then have the customers might actually have their own teams, but they might also outsource some of this work. So that's 3 organizations contributing to this same code base. So how do we make sure that this is maintainable? How do we make sure that we've got this application that people can productively contribute to? So we've got this code base. How do we structure that? We've got an application architecture. How do we make sure that we can it is maintainable, it's testable, it can change? We've got all these contributors. How do we make sure that all these different types of contributors can do so productively? It's a large code base. It's a complex application. Tests are fundamental to making sure that this is a quality application. So how do we make sure that it's testable? And how do we also have a productive developer experience? We want to be focusing on building features and adding value to our application, not messing around with making a simple change and it affecting everywhere else. And finally, all of this needs to be complementary. So it's not a simple solution, although hopefully I can explain it and it seems relatively simple. And maybe you guys are doing a lot of this anyway. So there's no point in me talking about one thing and introducing them because they're all complementary. This is a good thing about it. You do these things and you find that they complement each other. So the solutions are some sort of components, widgets, modules, so some sort of modular solution. I think features is a really good term. We call them blades because we're splitting the application into strips of functionality. We have a services layer. Most people kind of know around service architecture. I'll show why it works in our scenario and why it should work in others. Some sort of Vstar, consistency. Most people are aware of it. I'll tell you which one we use and why. And efficient testing, and I don't just mean fast. I mean reliable. reliable testing. We need to make sure that we can run our tests and we trust the output. And then how the tooling can support all of this. So that's what I'm hopefully going to try and convince you of now. So I'm taking Gmail again as a reference, and I'm going to split it into feature. As I said, we call them blades. I, again, like this compose view. I like the idea of this fully rich feature where we can search our contacts, we can compose this rich email, we can add attachments and so on, and send our emails. So that's what I mean by feature. These are what we call blades. So what problems does that solve? If we decide that that's the solution, what problems are we solving? So you've got a large code base. Standard in web development and in web apps in the past and websites, we would have some sort of assets folder, and we chuck everything in there, and we group by type. We'd have all our JavaScript in the JavaScript folder, all our CSS in the CSS folder. But when it comes to building a large application, it becomes really difficult, right? Which CSS file is this in? Which JavaScript file is this in? Where is that click handler defined? Where is that the CSS, the color for that button defined? So instead of throwing everything underneath an assets folder, what we do is we group by feature. We say, well, we have a folder name, and in there we have all the assets associated, everything associated with that feature, through to tests. So, the JavaScript functionality through to a testing. So everything is there under feature name. The second problem to address is that a larger application will probably take quite a while to load. Say I'm a developer working on the Gmail team, and I'm working on this chat feature, bottom left here. And I've made a change, and I want to see the result of that change in the UI. So I refresh the app. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'm surprised if you didn't walk out, because that felt to me like a lot longer than 10 seconds. So that's every time I make a change, and I want to see that the result of that reflected in my application, I need to wait 10 seconds. I'll probably end up in TweetDeck. I'll end up, going to making a coffee. I'll get bored. I'll disappear. We're saying that compilation is the new. No, what is it? Waiting for my test to pass is the new compilation. Waiting for my application to reload is the new compilation. So we've got this problem. We don't want our developer workflow broken. We want to continue seeing the result of our change and then diving back into the code again. How many times have you pulled the latest from your source control repository and it's broken the entire application? It's nothing to do with the piece of functionality you're working on, but still it's broken the whole application. And even if you can roll back, it's still broken your workflow. You're still stopping for 10 minutes while that's sorted, or you've thrown something at, or Nerf gunned somebody. So we need to avoid this kind of situation. I pulled down some code that's completely unrelated to the feature that I'm working on, yet it's still broken my app. So if we're talking about building features, we're talking about building features. So this is our FX tile running in the old Kaplan Trader 3, this might be now. So because all the assets are on disk together, because we know we want to solve all these problems, our solution was to allow us to serve our feature in isolation and develop our feature in isolation. So our tooling allows us and understands where these assets are on disk and knows what we want to do. So we can run our feature on its own. And this is something we call a workbench. But I'm sure as developers, quite frequently you've gone, well, I'm going to create this widget, this thing, and I'm going to create a little index page, and I'm going to add it, and I'm going to build it in there. And then when I get to a certain point, I'll probably then add it to the application. And we forget about our little HTML page that we created that helped us get to where we were. But we've gone, well, that's a really great way of working. That's a really productive way of working. So that's core to the way we approach doing this, and that fits really well with this idea of splitting your app into features. So we can run that test, that feature in isolation. We're unaffected by changes elsewhere because we're only serving the assets from our feature file, feature directory. We get fast reload times because we're not loading the full application and all of its dependencies, and it's easy to change. We know where the CSS is for our send button. We know where our JavaScript click handler is for that because it's under that feature folder under JavaScript. Now, this is just a kind of short intro. We've obviously got this idea of features, and we want to.
Sorry, you're talking about isolation on the previous slide.
Yeah.
When you say run in isolation, that means that you can run it in. What does isolation mean?
Run it in isolation. It does mean run that single feature on its own without any of the other application features needing to be run at all.
Right.
As I go through, hopefully, it will make sense. So global CSS, that fits into this next part. It's our specific solution. Head to the booth and I can answer that question by showing you. That's probably the best way. Yeah, so we've got this idea of, we've got all these blades, all these features, and we want to bring them into our application. We just do that with JavaScript. So there are multiple ways of doing this. Web components will do an HTML include. So we just go, well, we have an entry point, this aspect, this top level, which will have its own CSS and so on. And we can just require things in. So this is the feature that we've built. In our case, it's a view model. We're using Knockout as in our situation. But you can just require whatever it is, however you've decided to define your features. And then you just add it to the application. So you can see I've got multiple features. I require them in. Here I'm doing a bit of binding in terms of a Knockout component here, binding to a template. And then I'm just appending to the DOM. So the point here is just to show you it's really easy just to kind of develop it in isolation and then bring it into our entry point into our application. We have this idea of aspects where you might have a bit of, as somebody comes to load your application, you might do a bit of browser sniffing, which is probably naughty. But you might go, well, this is a desktop app, a desktop browser. It's got a high resolution. So actually, I'm not going to serve them all the rich blades, all the rich features, because it's just not viable to do things like inline images in the compose view, in a mobile view. And it's also maybe more intensive for the mobile device. So we can build our different features and we can decide in our desktop aspect, I'm going to bring in my rich email composer view. But when it's tablet or mobile, I can bring in a simplified email composer. But we can reuse our search feature across all of these devices because they work perfectly well. It could be that you do it and you use these features in different ways. You have advanced features or you have features which your users paid more money to have access to. And you could use aspects in that way as well. So I wanted to talk about how you bring these features in together. So I mentioned services was one of the solutions, and I haven't kind of talked about how our features communicate with each other because remember, we want to be able to remove features without affecting everything else. So this is where services come in. And they also help with testing, obviously. So services generally help you access shared resources. An example of that is inter-component communication, so inter-feature communication, because we want them to communicate in loosely coupled ways. They can't directly rely and reference on other features. Otherwise, when we remove that second feature, it will break the application. So we have, in our system, we have an event hub for this. But as long as you've got something there to provide loosely coupled messaging, that's a really good solution. Another example of service is a persistent service, something that stores to local storage or IndexedDB, or something that makes a web API call. It could be there's a database backend. It could be that you're doing some sort of CRUD manipulation on a RESTful resource. And in our case, real-time services. So we have a real-time service defined. In our case, our implementation is something called Streamlink, which is our own solution. But ultimately, when you get a service, you don't get an implementation, you get an interface. Now, I know this is JavaScript and it doesn't have interfaces, but ultimately it's a contract or a protocol. When you interact with an object in any language, you generally know that there will be these functions defined. It takes these parameters, it has these return values, and it behaves in this way. And that's all it is, and we use this idea in JavaScript. We've just provided a standard convention for it. To prove it's a really simple thing, it's not a massive enterprise pattern that we use, and that it really can be simple. Because I've given this talk a few times before, and a few people have said, you're moving J2EE to the browser. No, we're just taking a software engineering concept and using it in JavaScript. So in this example, we're creating, here the implementation uses something called Firebase. It's a chat service. We register it using a simple string identifier and pass that instance. So when any feature wants to use this, all it does is it goes service registry.getService, chat.service. Maybe we can wait at the end for questions. Is that okay? Yeah? Okay, we'll go for it.
So you're using the registry pattern here to expose access to other services.
Yeah.
And on the previous slide, you said that you have a different mechanism for that communication. I'm just very curious as to why you didn't unify the two.
Sorry, what was the first part of that?
Inter-component communication.
Yeah. So the event hub is registered with the service registry. So you get the event hub from the service registry. Okay? This is actually an example of a dynamic service locator defined by Martin Fowler. It's really simple. There are loads of different ways of doing this, dependency injection. But we've decided that this is just a really nice, simple mechanism. We're not injecting things into constructors and so on. So if we think about services, your front-end application, again, we've said it's complex. It's going to have a lot of back-end dependencies. You need all those dependencies to be running, all these back-end services to be running in order to launch your application. Now, that can be a pain again, because if we're thinking about building that compose view in Gmail, why do we need the authentication service running and the database service running and the real-time service running? Why don't we just need our contacts and maybe email sending RESTful services running? So because we've got this service registry and because we run our components in isolation, we can obviously do something like this. So if I'm just building my login view, my login feature, I only need my authentication service running. If I'm building the latest news feature, I might just need the real-time service running. So we get the benefit there. But not only that, because of this service registry, we don't actually need any of the real services running. We can just create our implementations in JavaScript, make sure they behave in certain ways, and we don't need the backend services running with all their own runtime, all their own configuration, and so on. And this is really useful in some situations where maybe there's another team building a service that you rely on and you need, but it's not going to be available for a month. So you can have a chat with the team that's building it, say, hey, what sort of data will I get from this service? How shall I be interacting with it? How should it behave? And you can write your implementation entirely in JavaScript, and then when the real service is available, you can change your implementation, create a new implementation that interacts with the real service. So this is why we use services. Firstly, we've got this event hub that makes sure that our features don't directly communicate with each other. We can easily change implementations. As I mentioned, the service isn't available. We've got a fake service there. When the real one becomes available, we can add a new one. Or it could be that we decide that we're going to get our latest news from a web API that we poll every 10 seconds. But then we go, hey, that's crazy. That's not really real time. Let's add this functionality to a streaming service. So we change our implementation. We create a new implementation that connects and gets that data from a streaming service. We don't need to change our feature functionality, just change that implementation that we're using. And one of the important things we've got from this is that we can actually change the implementation that's used in our different runtime scenarios. So what I mean there is you've seen the Workbench. We obviously have a testing scenario, and then there's running the full application too. So in this situation, we've got our Workbench. Now, on the left-hand side here, we've got a prices Workbench tool, we call it. And what it's done is when it was instantiated, it's registered itself with the service registry, and it said, hey, I'm the real-time service. So when this instantiates itself, and it goes to the service registry, get me the real-time service, it doesn't know, but it's actually got a reference to code that this is providing. So we don't need our real-time service really running. We can control the data that's being sent through to this, and it's actually quite a nice development workflow. You can say if there's certain values where this should behave in different ways, you can control this from here. You can write your own little tools that provide that service functionality. Obviously, in tests, you can inject different implementations in tests. In the Workbench scenario, you've maybe created a test double that lets you control how it behaves. So you can inject that and use it as part of your testing. You can use a mocking framework and push in a mock and assert the interactions that are being made from your feature against these services. And then when you run your full application, you make sure that the real implementations of these services are part of that deployable bundle. So I haven't mentioned Vstar yet. So we've specifically chosen MVVM, and the reason we chose it was actually to allow us to efficiently test these applications. So to understand why, I kind of wanted to talk a little bit about how we used to do things, and this is as far back as 2009, where we had these requirements, IE6, Firefox 3.5, I think Chrome. But we did, we had a continuous integration environment. We were doing a lot of unit tests against each of our classes. We do object-oriented JavaScript. And we had these application acceptance tests. Now, to qualify that, I'm talking about things that make sure you're meeting your business requirements. So, you've got to have a diagram here. You've got to have the triangle. So, you had a lot of nice unit tests. We had some application end-to-end tests. And we use Selenium for our testing. Can I ask, who uses Selenium now for their tests? Okay, quite a few people. Cool. And we'd abstracted away from the standard selectors and locators and so on. We'd got some kind of business-focused Selenium extension, Selenium user extensions, so that our code just looked like it was providing, that level of abstraction which made our tests much more readable. For instance, get the FX tile, execute a trade, and so on. And we even abstracted further and created something like this that let business analysts, I don't think we actually had business analysts doing it, but it would allow someone to, human readable, go, right, I'm going to write a test that defines this spec. And we had this infrastructure for our continuous integration. Now, this is the process we went through. We would pair up our browsers. So we would pair up two VMs, one which would offer browsers, one which would offer back-end VMs. Now, the point here is that your back-end sometimes need to behave in certain scenarios to test edge cases. For instance, a service is down, or when a certain value is sent, it needs to be set up in order to behave in a certain way. So we'd pair these two VMs up. We'd obviously reset things to make sure that there's no state transferred from another test. We'd launch a new browser, which loads the application. We'd execute our tests, which would interact with the back end, save the results, reset the back-end services. We'd actually kill the browser, kill the process, open up a new one, launch the application, execute our tests again. So I think that kind of makes sense. It seems like we were doing the right thing. So we can ignore the unit tests, but we had around 500 acceptance tests around this application, Kaplan Trader. And we had 50 VMs. It might have actually been 100 VMs that we paired up. So that allowed us to run these tests in parallel. So, we can have, our Firefox executing the same tests as Chrome at the same time, and then the same as IE6 and so on. The problem we had was that it took 8 hours to execute these tests. So that's too long. I think we'd all agree that's a little bit too long. And also, the worst thing is that the tests were highly unreliable. We could take that same change set or that same check-in and execute the same set, the tests on that, and we'd get different results each time, which isn't efficient. So we actually had to run these set of tests at night when everyone had gone home, when most people had gone home. And not only that, we had to have a smoke set of tests. So for every check-in, we still ran some of these tests, but we just defined some basic functionality that we wanted to make sure worked. So that's inefficient testing. We had a bunch of problems resetting back-end services. Some of the services wouldn't restart. It's technology, things sometimes go wrong. So we'd end up doing things like testing our test environment as part of our tests and not the functionality that we're changing and building, which isn't what we want to be doing. So there were two kind of outputs from this. The first thing is that as much as possible, we wanted to avoid any I/O. So any network requests as part of this, any access to real back-end services, we were trying to avoid. The second thing is that we found that accessing the document object model and making assertions against that was highly unreliable. But you remember that we've got this service registry. So it means that we can actually avoid accessing real back-end services. We can still do some integration testing, but in terms of testing our features, we can use our fakes or our testables to make sure that our feature is interacting correctly with services. So we've got a solution for that. But where MVVM comes in is that, as I said, we found the DOM to be highly unreliable. I don't think we really ever tracked it down, whether it was a timing issue. If you ever write a Selenium test of some sort, you'll see that there's loads of set timeouts in there waiting for the DOM to render. We just found it to be highly unreliable, and we decided we just don't want to be touching the document object model anymore. So our solution for this was to use MVVM because the view model is a logical representation of the view, and we entirely trust Knockout in this scenario to deal with binding the view and rendering that view based on the state of the view model. And also, when the user interacts with the view, we know that it's going to update that view model in the right way. So we entirely trust Knockout to do this for us. You remember we still do have some Selenium tests for testing the full application with backend. But the real win comes when we take this idea of services and the view model and put it together, because what we can do is we can inject a mock service into the services layer. We can interact with our view model and make sure that the correct interactions happen against services. We can put in our test double that we've maybe even built during our Workbench, get it to behave in certain ways, which executes our business logic, and then we verify the state of the view model from that. So we're testing our full feature in isolation in the same way that we can run it. So we're not doing any network requests. We're not relying on the DOM rendering things, but we're still executing our full piece of business functionality. So the diagram changes to something like this, where we still have a lot of unit tests, but we've got these Blade functional tests, these feature tests. As I said, we still have these Selenium-based tests for making sure that the full integrated stack works, and we still have some manual tests. So the proof in the pudding, as it were, is that it used to take us 8 hours on all this infrastructure, and it now takes us 30 minutes on a single machine to do that same coverage of tests. But not only that, because we're encapsulating all our functionality and features, and we know that we've got this loosely coupled architecture in terms, and we can add features and remove features without it breaking the full application, it means that we can, as a developer, you can just test your single feature before checking in. Now, if you want to be completely conscientious, then you will probably run the full set of tests, but it means you can do this sort of stuff. And it means you'll get feedback quickly from the continuous integration environment if something has broken. So I want to now just talk about how tooling helps the developer workflow and how we're focusing on building features. So the workflow that we try and aim for, and I think most people kind of do a similar thing, is we want to create a skeleton for our application. So we want to be doing things in consistent ways. So our applications will generally kind of have some commonality between them. So our tooling helps us build that application skeleton. So we know where our assets are on disk, we know where the folders are, directories, where to find assets, and so on. The next step is, right, I've been tasked with creating a feature. So I use the tooling again to create a skeleton, the scaffolding functionality to create a skeleton which builds the basics from my feature and puts that in place. I can then change JavaScript, HTML, CSS. I run tests, write tests, so maybe write my tests first and then execute against the code. I can run it in isolation in that idea of the Workbench or in your standalone page, however you want to do this. I can manually test that feature because it's nice to see how that's actually reflected in the UI and how you're building that functionality. And then I can iterate through until my feature's complete, and then I do that step where I integrate it into the application. And you probably have some tests that you'll write there and run before, like maybe doing some manual testing, going through QA, and there'll be a build and deploy process. So it's quite a simple workflow that works quite well. So how does the tooling fit into all of that? So there's quite a trend at the minute for developer tooling, around developer tooling specifically in Node, and one of the driving factors behind it is to identify things that we're repeating and then to automate those things. But that's nothing new. That's what we've probably been doing since we started writing code. We're trying to identify things and automate them. So things like, in our case, we want to automate the creation of this application structure so that it's consistent and so that we're promoting this standard workflow that no matter who's on a team, they know how an application is structured. If somebody new comes along to that app, they know where to find assets and how to change things. So things like scaffolding, a development server, which is obviously a core part of building a web application, that's inbuilt into the tooling. We have the support for builds and bundling, so we know in these different scenarios how to bring these assets together and serve them, for instance, in the Workbench view, and also how to create a deployable asset. So most people have seen, like grunt tasks, which will say, here's the dev mode, and here's the live mode, or the deployable asset that we put into production. So that's part of the tooling, and you'll probably see that as part of tooling. And testing, and obviously as well. Do you want testing part of your automated workflow? The one kind of differentiating factor, I think, in terms of some of the stuff that we do is, if you look at things like Grunt and Gulp and Broccoli, they talk about files and files on disk, which can differ between multiple applications. But if you know the structure of your application, then you can write a level of abstraction and a bit more intelligence into your application so that it can do things like serve the files located in a certain place on disk in a Workbench. So I want to go into that a little bit more. The first thing is compliance. So as a developer, it can be quite frustrating to be told how to do things. Having said that, when you're building these large applications and when you have all of these things to consider about building these large apps that need to be maintainable and will be around for quite a while, you do need to enforce some things. That can be as simple as plugging JS hint into your tooling so that you make sure that people are conforming to your JavaScript guidelines, or more intelligent things like I've said that these features cannot directly reference code elsewhere. A feature A cannot say, right, I've seen there's a nice bit of code in feature B, I'm going to use that. Our tooling knows about the structure of our applications. If it sees you try and reference code in feature B from feature A, it will blow up. It will say, you cannot do that. So this sort of stuff can be built into tooling to really make sure that you're doing things in a defined way. If it understands some of these scenarios, it can help you with that. So, we can run things in workbenches, we can build bundles and execute tests, and we can run our application from our development tooling as well. Another example is that there are a few examples of things trying to do. There's something called asset graph written in Node at the minute that's looking to do something similar to this. We write our code in this kind of style. So, it's Node.js style because it's module.exports and not just exports dot something. So we kind of call it Node.js style. Ultimately, we just want a nice way of writing code. But one of the great things about this is that our tooling can analyze these requires and build up a dependency tree and work out what it is it should be bundling. Not only that, because we know that these features have their CSS, their JavaScript, their HTML, their images on this together. If we see a reference to this input feature, we go, right, well, we also should bundle the CSS, the images, the I18N, and so on for this. So this is an example of the output. So you can actually just run the tool and say, okay, what are the dependencies for this entry point? For this workbench, what will be served? For this application, which files will be concatenated and in which order? And obviously, this is kind of just done on the fly when you're in development mode and you're using the development server. And the final thing to talk about is that we don't want to restrict people too much. What we've done is, when we open source, we actually rewrote a lot of things again, and we identified things that might change. So an example of that is the coding style. Now, we didn't used to write code like this. We decided that this was quite a nice way of writing code. But this might change. We've already changed it once. So we've made this a plugin. We've made the bundling process and the dependency analysis part of the tooling a plugin. So identified those things that can change, and that will allow you to go, right, well, that should be a plugin. That should be something that I can change in the future. So it might be that in the future we want to use TypeScript, or we want to use CoffeeScript, or we want to use ES6. So we need to be able to change that plugin, the implementation of that plugin. Other things are just executing commands. So I've said we've got this rich domain model which represents the structure of our application. Now, we want to be able to access that through an API and write our tools against that rather than just copying files around. So we need a command API. And the other thing is testing. So at the minute we used JS Test Driver, which is probably coming towards the end of its life. It's not really being maintained. So we've obviously identified that as something that we want to change in the future. So think about the things that are going to change in your workflow and make those easy to change. So hopefully I've proven a number of things there. The stats alone show that we've gone from 8 hours for testing. We're down to 30 minutes. We're building these complex front-end trading applications that large financial institutions are using to execute real live trades. And the way that we've done that is we have split in our application into features. In terms of the code base, we've done things with architecture. Features are obviously a part of that. We've used this services layer and MVVM, all part of this architecture. Contributor harmonies through separation of concerns kind of across the board, from code base through to architecture, allowing us to make sure that when we change code, it's not going to affect others. When we run the application and make changes, it won't affect others, even if it breaks our piece of the application. And we're promoting quality. The decision to use this services layer and to use MVVM was directly about, is it testable? Can we really make sure it's maintainable? And then the predictive developer experience is all about really the tooling to support all these decisions that we've made. And I think you can tell that the fact that we're using the same points across each of these is saying that these are complementary. They do work together quite well. So we've got apparently 14 minutes left. That's it. Any more questions? Maybe I can answer your questions a bit better now.
I'm interested in how you found knockout resource usage as you've got rising components. Has it been linear?
So we took Knockout at 1.0 probably 3 years ago. There wasn't really a lot of other choice around then. We specifically wanted a solution that offered this MVVM idea, and we built on top of it something called Presenter. So we use Knockout, but we actually, in our trading applications, we actually use something Presenter with a slightly modified version of Knockout underneath. Some templating stuff. So we have an HTML service. So we've got our features and we've got our HTML templates in there. The way that Knockout works is it expects the HTML templates to be defined in the DOM. So we wanted our own way of loading these HTML templates. In terms of resource usage, I haven't been involved in doing this testing. As part of our CI, we do have some feedback in terms of what memory usage we're using in certain views. It was quite a modular view with different tabs. We'll open up different tabs and we'll execute the application and do some things using Selenium for a bit and just watch that graph. And it isn't something I've really been involved in. But maybe if you come to the desk, if some of the guys there might be able to help. Any other questions?
Since you mentioned that this is mainly for long-lived applications, so you will open the application in the browser and will live for a week open. How do you deal with changes in the RESTful API?
Okay, so the question is, this is generally being developed for long-lived applications, and how do we deal with changes in...
You open the browser and it's working with version 1 of your RESTful API. What happens if in the middle of the week you change to version 2 of the API? What happens with the...
Okay, so how would it affect people making changes to RESTful APIs that maybe aren't part of that code base? Something it might be out of your control because it might be a different team. Communication. I don't think there's a silver bullet for that. I think your teams need to be working together. There are various solutions in terms of versioning API endpoints. Our interaction with backend services generally are through a streaming API, and we control the full stack. So it hasn't been something we've generally had to worry about too much because it's within our control at Kaplan. So, sorry. Any other questions? Yeah. Okay, so the question is, do we have a built-in mechanism for separating things like templates for I guess, different devices and so on? I mean, we would probably do that at a feature level, so it probably wouldn't be something we do in any other mechanism. I mean, the question that the gentleman asked over there around, so you probably have some global styles, what happens there? Now, the idea of aspects can have their own CSS, and that will bleed through to the blades when they're added to, with the features when they're added to the application. But we don't have any built-in kind of support for the sort of thing you're asking. It would just be, well, if it's that different, then you probably build the same blade. And if you think about the way that you build applications and you refactor, when you identify those core pieces of functionality, you'll probably shift it out to a library, and you'll reuse that business functionality within the blade or the feature that's for that iPad and the feature that's for the desktop. So you just try and push that out somewhere else. Okay, any other questions? Yeah.
But also there is that separation from the view. I'm just wondering, how do you test for things like visual regressions?
So we don't actually do that. The question is, how do we test for things like visual regressions when we're not doing any kind of DOM checking of the DOM and seeing how it's really rendered in the browser? So I know in the past people have done things like screenshots and do comparisons, and I know a lot of media agencies that they take that, and that is highly important to their application. Now, obviously, we've got a dedicated UX department. They'd probably love that sort of stuff, but when it comes to changing little pixels in a button that executes a trade, unless it's going to affect that, I've clicked on 100 million rather than 10,000, it's not going to make that much difference. But yeah, I mean, there are solutions out there that will do that as part of running applications. They'll take snapshots and be able to do a clever comparison about images that have been generated, so you'll know when there are visual regressions. Okay. Is it lunchtime? Yeah, you're all early then. So great, enjoy. We've got a booth. Please come along, say hi and grab a t-shirt. Thank you.